ever wondered if there's a hidden giant lurking at the edge of our solar system? Scientists might just have found it. Welcome to our channel, where today we're diving into the thrilling mystery of Planet 9. Yes, you heard that right. There could be another massive planet right in our cosmic backyard. And guess what? New strong evidence has just been unveiled by scientists, bringing us closer than ever to confirming its existence. So stick around, because what we're about to reveal will not only blow your mind but might change everything we know about our solar system. Let's get started. The second practice involves taking a step back in time to explore the fascinating history of the search for Planet 9. The hunt for this mysterious planet isn't a recent endeavor. It actually stretches back to the mid-19th century, when astronomers first suspected that an unknown object might be influencing the orbits of the outer planets. One of the earliest theories came from the discovery of Neptune in 1846. Back then, astronomers noticed that Uranus wasn't behaving as predicted and postulated another planet's gravitational pull might be at play. This led to the quest for Planet X, a term originally used before we started calling it Planet 9. Fast forward to the early 20th century, when the famed astronomer Percival Lowell devoted years to searching for this hidden world. Despite his thorough efforts and even founding the Lowell Observatory specifically for this mission, Planet 9 remained elusive. The discovery of Pluto by Clyde Tombaugh in 1930 initially seemed to solve the problem. However, Pluto was soon determined to be too small to account for the gravitational effects observed on other outer planets, so the mystery deepened. In more recent times, advancements in technology and a greater understanding of our solar system have reignited interest in Planet 9. In 2016, astronomers Konstantin Batygin and Mike Brown from Caltech presented compelling mathematical evidence for the existence of this massive unseen planet. Their research showed how the orbits of several distant Kuiper belt objects were being influenced by a large, unseen body. Despite ongoing searches using powerful telescopes, direct observational evidence remains elusive. The search for Planet 9 is a tale of scientific perseverance and curiosity, highlighting the vast unknowns still lingering in our own cosmic neighborhood. The current evidence that suggests Planet 9's existence is nothing short of fascinating. Recently, scientists have collected a wealth of data from advanced telescopes and space observatories, painting a clearer picture of this elusive giant. One of the strongest pieces of evidence comes from the observation of peculiar orbits of distant trans-Neptunian objects, or TNO, in the Kuiper belt. These icy bodies exhibit clustered and highly elliptical orbits that simply can't be explained by the known planets alone. According to Batygin and Brown, the only logical explanation is the gravitational influence of a massive, unseen planet, estimated to be about 10 times the mass of Earth. Moreover, surveys using the Subaru telescope on Mauna Kea in Hawaii have provided additional support, identifying more TNOs whose strange trajectories align with the presence of a distant, large planetary body. But why is this evidence stronger than previous claims? For starters, the mathematical models used by Batygin and Brown are more refined, with simulations demonstrating consistent results that predict Planet 9's influence on the orbital patterns of these distant objects. Additionally, the recent evidence doesn't rely on a single anomaly, but rather on a collection of observed behaviors across multiple objects, making the case for Planet 9 more robust. Furthermore, advances in infrared astronomy have allowed scientists to rule out other potential explanations, such as chance alignments or the presence of a smaller, less influential object. The combined observational and theoretical data forms a compelling argument that we could indeed have another planet lurking at the fringes of our solar system. As technology continues to advance and more data is gathered, the hope is that we'll finally capture direct observational evidence of Planet 9, confirming its existence once and for all. The methods scientists use to detect Planet 9 involve a fascinating blend of advanced technology and keen observational techniques, but how exactly do they track something so elusive? One key method is through analyzing gravitational effects. When you think about it, gravity is like an invisible string that connects objects in space. By observing how known objects like trans-Neptunian objects or TNOs move, scientists can infer the presence of a hidden gigantic body affecting their trajectories. But what exactly does this mean? Imagine you're watching a group of leaves floating on a pond. If they suddenly start moving in a specific pattern, you might suspect there's an unseen fish swimming underneath. The same principle applies here. The clustered and elliptical orbits of TNOs act like those leaves, hinting at something massive lurking out of sight. Are you following along so far? Next, let's talk about orbital anomalies. Normally, objects in the Kuiper belt should have a scattershot distribution, like confetti thrown into the air. However, many of these objects have orbits that are strangely aligned or tilted, which can't be attributed to the gravitational pull of the known planets alone. This is where Planet 9 comes into play. Scientists propose that its massive gravitational force is responsible for these unusual alignments. It's like having a magnet beneath a table. Even if you can't see the magnet, you can tell it's there based on how it influences metal objects on the surface. Does this analogy make sense to you? Now, how do scientists observe these subtle clues? This is where cutting-edge technology comes into the picture. Telescopes like the Subaru telescope in Hawaii and the Atacama Large Millimeter Array in Chile play a crucial role. These powerful instruments can detect and capture detailed images of distant celestial objects. Additionally, advancements in infrared astronomy have been pivotal. Infrared light can highlight objects that are too dim or cold to be seen in visible light, allowing scientists to observe phenomena that were previously hidden. Think of it as night vision goggles for the cosmos. Isn't it amazing how technology opens up new windows into our universe? Finally, let's consider the role of mathematical models and computer simulations. Astronomers like Batygin and Brown utilize sophisticated algorithms to simulate the gravitational interactions within our solar system. By tweaking the parameters to include a hypothetical Planet 9, they can see if the simulated orbits match the actual observed data. And guess what? The results are strikingly consistent. It's almost like solving a complex puzzle where each piece fits perfectly only when Planet 9 is included. Have you ever solved a puzzle and felt that satisfying click when a piece snaps into place? That's the kind of moment scientists experience when their models align with observational data. So, what do you think about these methods? Do they make the search for Planet 9 sound more tangible? These sophisticated techniques not only showcase human ingenuity, but also underline the relentless pursuit of knowledge that drives scientific discovery. As our technology continues to advance, who knows what other hidden secrets of the universe we might uncover next? Now, let's move forward and discuss the future steps scientists plan to take in the search for this mysterious planet. The potential characteristics of Planet 9 are as intriguing as its mystery. If it exists, scientists estimate that Planet 9 could be about 10 times the mass of Earth, making it a true giant in our solar system. To put that into perspective, it's smaller than Neptune but significantly larger than any of the rocky planets like Earth or Mars. Its enormous mass would mean it has a powerful gravitational influence, capable of affecting the orbits of distant objects in the Kuiper belt. But what about its composition? Based on our current understanding, Planet 9 is likely to be a gas giant, possibly similar to Neptune and Uranus. This means it could have a thick atmosphere composed mainly of hydrogen, helium, and possibly methane, giving it a blue or blue-green appearance. Unlike the gas giants that we are familiar with, it's also speculated that Planet 9 could have a solid core surrounded by this gaseous envelope. Imagine it as a distant cousin to Neptune, but with its own unique quirks. Another fascinating aspect is its distance from the Sun. Planet 9 is hypothesized to be orbiting at an extreme range, possibly 400 to 800 times the distance between the Earth and the Sun. This means it would take thousands of years to complete a single orbit around our star. Its distant orbit places it in a frigid region of the solar system, where temperatures plummet to hundreds of degrees below freezing. This extreme distance and the resulting cold environment would make it a very different world compared to our inner solar system planets. What makes Planet 9 unique compared to other planets in our solar system is not just its potential size and distance, but also its mysterious origin. It may have been formed much closer to the Sun and then ejected to the outer solar system through gravitational interactions with other giant planets. Alternatively, it could be a captured rogue planet, a wanderer that was snagged by the Sun's gravity as it passed by. This intriguing possibility adds another layer of mystery to its story. Additionally, given its distant orbit, Planet 9 could possess a host of undiscovered moons or even a faint ring system, similar to the rings of Saturn but possibly less pronounced. Imagine what a spectacular discovery that would be. So as we continue our quest to find this elusive giant, we can't help but marvel at the potential characteristics that set it apart. Its size, composition, distance, and unique origins make Planet 9 a captivating subject of study. As our technology and techniques improve, we inch closer to uncovering its secrets and adding a new chapter to the story of our solar system. Now let's delve into the future steps scientists plan to take in the search for this mysterious planet and consider what new discoveries might be on the horizon. The implications of discovering Planet 9 are profound and far-reaching, both scientifically and in terms of our broader understanding of the solar system. Scientifically, the confirmation of Planet 9 would revolutionize our understanding of planetary formation and dynamics. It would provide a fascinating case study of how a planet can influence the architecture of a planetary system from its distant perch. As Professor Konstantin Batygin of Caltech, one of the leading proponents of Planet 9, puts it, finding Planet 9 would solve one of the biggest mysteries in planetary science, the odd aligned orbits of objects in the outer solar system. It would also likely spur a wave of new research into the dynamics of our cosmic neighborhood. Such a discovery would necessitate a re-evaluation of existing models of the solar system's formation, possibly requiring scientists to consider more complex scenarios such as planetary migration or the capture of rogue planets. This could lead to new insights into the early history of our solar system, shedding light on how the current arrangement of planets came to be. Beyond the scientific community, the discovery of Planet 9 would capture the public's imagination, much like the discovery of Neptune or Pluto did in their times. It would symbolize the continued capacity of human curiosity and ingenuity to uncover hidden secrets of the universe. As NASA astrophysicist Dr. Jennifer Burt states, discovering a new planet in our own solar system would remind us that there's still so much we don't know about our own backyard. It's a humbling and inspiring notion that drives the pursuit of space exploration. Additionally, the potential cultural and educational impacts are significant. The discovery could inspire a new generation of astronomers, scientists, and engineers, much like past astronomical milestones. Educational curricula might be updated to include the latest findings about Planet 9, fostering an enduring interest in the sciences among students. The broader philosophical implications are equally intriguing. It would challenge us to reconsider our place in the cosmos, as the realization that our solar system is still full of hidden wonders underscores the vastness and mystery of the universe. In the same way that the discovery of exoplanets has expanded our understanding of planetary systems, finding Planet 9 would remind us that the frontier of discovery isn't limited to distant star systems. It's right here in our cosmic neighborhood. Imagine the sense of wonder and awe as we come to terms with the fact that in the 21st century, we are still finding major celestial bodies in our own solar system. The implications would undoubtedly ripple through scientific communities, educational institutions, and the public imagination, reinforcing the importance of continued exploration and study of space. As we advance in technology and observational capabilities, the discovery of Planet 9 stands as a symbol of the unknown yet reachable wonders that await us. Planetary scientists and astronomers around the world eagerly anticipate the day when we might finally gaze upon this mysterious world, adding a new chapter to the grand story of our solar system and highlighting the endless possibilities of the unexplored. So as we continue to push the boundaries of our knowledge and explore the cosmos, the hunt for Planet 9 remains one of the most exciting and promising endeavors in modern astronomy. In summary, we've explored the captivating mystery of Planet 9, delving into its historical background, the compelling evidence that fuels its potential existence, and the sophisticated methods scientists used to search for this elusive giant. We've also speculated on its intriguing characteristics and pondered the profound implications its discovery would have on our understanding of the solar system. The new evidence presented by scientists, particularly the unusual orbits of trans-Neptunian objects and refined mathematical models, brings us closer than ever to confirming Planet 9's presence. This groundbreaking discovery could revolutionize planetary science, sparking new research and reshaping our cosmic perspective. We hope you're as excited as we are about the potential of uncovering this hidden giant. Stay tuned to our channel for future updates on the hunt for Planet 9 and other fascinating space mysteries. Don't forget to leave your thoughts in the comments below, and if you enjoyed this video, be sure to like, subscribe, and hit the notification bell so you never miss an update. Thank you for watching, and remember, the universe has many secrets left to reveal.